Okay, in last session we have seen the PWM. Now what we want to do, instead of hard coding the numbers and running through the for loop, we are generating the on time. Okay, so instead of that we can do same thing with an input. Okay, so from here we are going to need few things. Let me copy those. Okay, so we are going to need these things in our project. So I've copied it, and what now I'm going to close this project. Let's first close this project. Now we are going to create a new project, new STM32 project. Now here we are going to design a dimmer circuit, okay, light dimmer circuit. STM32F0PC8T6. Next, so I'm going to name it as dimmer. Let's finish this. Okay, for dimmer, we are going to need to generate a PWM. For PWM, again, we are going to do the same thing. So channel PWM generation or output generation. Here, what we are going to do, we are going to make it 255. Now, we are going to need an ADC input to control, yes, the dimming of the bulb, okay, or light. So here, we are going to make channel 1 as an input. That is your pin A1, which is connected to the pot on your board. And after this, we have to enable continuous conversion mode to change the rank to 39. So 239 cycles you have to set here. Okay. The number of cycles you are going to get, not stable output you are going to get. Okay. So these two things are done. This one is our analog input and this one is our PWM output. So let's save this. Yes, I want to generate the code. Okay. So now here we are going to need our analog write function that we have written previously in our previous code. So that we have copied earlier. So to paste that function before your int main. So here is a analog write function from previous code, and now here how to use it. So simply here we have to call the PWM start. Okay, so that too we have written in our previous code. Let me copy from there. PWM start channel 1. Okay, now so this part was from your for loop. Okay, so what we have to do? We have to control the brightness of the LED or your on time of PWM using ADC. Okay, so how to do that? So very simple. We have done all these things previously also. Now, first we need to read the values from the ADC. So for that we have already written the code for ADC. So HL underscore ADC underscore start this ADC. So and HADC1, the handler is ADC1. So after this HL, so we have to do the polling ADC poll for conversion. Done. Timeout is HL underscore max underscore delay. Done. After this we are going to read the value from the ADC. For that we are going to use HL underscore ADC underscore get underscore value, and here we have to pass the handler. We check ADC get value and we are going to put the handler. Okay. Now we need one variable to store this value. So we'll declare one variable over here before starting the ADC, sorry, PWM. So to store the value, suppose you and 32. You can use 16 also, no problem. ADC underscore value is equal to, initially it will be 0. We come here, we are going to store this. The, this line is going to read the value from the ADC, so we have to store that value. ADC is equal to. Now what we have to do, we have to send this value to the PWM. Okay, now for that also we are going to need one variable. So let's write you int 16 underscore t. So dimmer value. I'm declaring a variable known as dimmer value. Now here what we are going to do, simply dimmer value. Let's put 0 initial in this. Okay. Now after this we have to do a little bit of conversion. Now what conversion we want to do? Right now our PWM is 16-bit. Okay, so it can go up to 65535. That is 0 to 65535, total 65536 steps. But what we have done, we have limited it to 255. So in our current code, the maximum the PWM step can go up to 255. Now the ADC is of 12-bit. Okay, so it can go up to 4095 or total 4096 steps. Okay, now the problem is that, so this is only nearly, what I can say, nearly 8% of this whole value. Okay, so if I move the pot a little bit also, this limit will be reached. So what we have to do, we have to map this value with this, means your PWM 0 with the ADC's 0 and PWM's top part with ADC's top part. Okay, so for that what we are going to do, simply there will be a simple formula what we can do. So dimmer underscore value is equal to ADC value divide by 16. Okay, very simple idea, divided by 16 only. Yes, because if you divide 4095 by 256, you'll get this 16. So we are doing just opposite, in opposite way, and this value we are going to pass to our analog right instead of value of r. So let's first, what we have to do before building, get hex file, right click over here. So post build outputs, check for your hex files, apply, rebuild, apply and close. Let's build this code. Okay, now what we have to do, let's go to the Proteus. Here what we are going to do, our PWM output is at PA6 only right now. So what we are going to do, simply we have to add one pot. So let's go here, your pot HG, we are going to put it for PA1. DC source is there. Let's make it 3.3. and after that we need to put one ground. Let's save this. Let's upload the code. So dimmer is there. Debug dimmer.hex. Okay. Let's run this. Okay, let me check. We're not getting any supply here. Okay, we do have supply over here. Dimmer.hex. Okay. Okay, let's check what is the issue with this. So let's check the code. Mm, okay, so this limitation we have provided is not being saved here. So let's save it now. Let's build it again. Let's get back to the Proteus. Let's run the simulation. Okay, so it is running now, and if I decrease this value of the port, yes, you can see that the width of waveform, that is on time of waveform, is decreasing too. Okay, same while we are increasing it, same the value is on time is getting increased. Okay, now let's move to the hardware for same code. Stop the simulation over here. Let's connect the board. Let's go to ST-Link, open file, data, your PVG workspace, your dimmer, debug, X file. So X file is open the target. Here hold your reset button, release this button and start uploading the code. Okay. Coding is done. Let's see how it works. So this is our circuit. Now what we have to do. So now our input is connected to the port. Okay. So port is PA1. So what we are going to do, we are going to use the jumper. So right now we don't need the jumper with the LCD. So we are going to remove it and we are going to connect it to the PA1, which is connected with our port. Okay. After that we have only one onboard LED, which is present over here. So what we are going to do, we are going to connect the LED with it using a jumper wire. So we are going to use a blue jumper wire over here. So our output is at PA6 and it will be connected to this LED. So now let's rotate this spot. Let's see that is working as we want. So as I'm going towards the VCC, you can see the brightness of LED is increasing. Yes, you can see that the brightness of LED is increasing. Now we will save this code. Later on, using same code, we are going to control the motor speed. Okay, after learning the motor interfacing, so this is how you can control brightness or motor speed using your PWM, your actual LED dimmers. Now there are smart bulbs whose light intensity can be controlled, colors can be controlled. So same PWM signals are used for those. Okay. So we are going to see few things in your next lecture. Now what you can do. Now right now what I am doing, I am feeding the input of pot at the ADC. Instead of that, what you can do, you can feed the input of LDR, and as the light on the LDR reduces, you can increase the brightness. As the in the morning, the LDR gets exposed to light, your LED's brightness is going to reduce. You can make such arrangements. Okay. Or if you're having LM35, what you can do, as the temperature increases, you can increase the fan speed like we are doing here. We are increasing the brightness of the light as the voltage of the pot is increasing. Same thing you can do with the LM35. As the temperature of home increases, you can increase the speed of fan. That is very easy. Okay, so we are going to see few more things in the next session.